My name is Jahromi, and I'm working under supervision of Dr. Jahromi. My research is about copper mostly. So as you know, 70% of copper is in the form of chalcopyrite, and one of the most major chalcopyrite contaminant is energite. Energite is one of the minerals contains about 8% of arsenic in the concentrate, and it's a major concern for environmental issues. So because energite contains arsenic and it makes most of the processing methods unviable, we are trying to develop a process based on using activated carbon and hydrochloric acid, which is good for environment and also viable for industry. So in this experiment I'm running here, we have some sort of reactor with heater jacket to keep the temperature up. One of the temperature we are working on is mostly like 80 degrees C and 90 degrees C, which is viable to apply in industry. And we have a copper solution. As you can see, the green light color is from the copper, which is dissolved into the acidic media here. So we have our particles of our activated carbon beads to help us to improve the process of leaching. So these carbon beads help us to oxidize more and more of those minerals into the hydrochloric acid, and we are also sparging oxygen through this reactor to improve the oxidation process. The media of leaching is mostly hydrochloric acid and some ferric sulfate solution in it to improve the leaching. So when we put energite concentrate inside our solution, this energite concentrate starts to dissolve in the presence of activated carbon and oxygen sparging. And the copper leaches and comes to the solution and makes this nice green color here for us. And with this method, we are separating all the copper from the energite material, and also we dissolve all the arsenic and separate it from the gangue. After that, the arsenic precipitation is happening autonomously inside the solution and make a ferric arsenate or scorodite, which is very safe for the environment and it's easier to dump it in the environment. So it's not, the contamination decreases a lot with this kind of method, and we can recover all the copper from the energite. We reached about 99% of copper recovery after 4 days of operation, which is pretty good for us. When we dissolve arsenic into the solution, we need to change the arsenic 3 to arsenic 5 to be more safe for the environment. After the changing arsenic 3 to 5, which with the help of this activated carbon beads, we precipitate out the arsenic in the form of scorodite, which is much safe for the environment. So when we have scorodite, it doesn't dissolve to the water or groundwater system or coming to the water table. So this is exactly what we are getting out of the process, which is the safe form of arsenic. And we already separate the copper in the solution and we recover the copper after all.